Well, good day, Internet. This is a video about troubleshooting your bike when you're finding it hard to start, and even if it starts and runs crappy or has some hesitation or whatever. So this is focusing on the ignition system. Fortunately, there's a few key areas that are common failure points or issues, and that being the spark plugs, the battery, some of the wiring, and then we'll look at a few tips and tricks that I've got along the way and help you get you back on the road. So here we go. First off, if the bike's not starting, the obvious place to me, is the run switch on off. Click it on and bang, it goes. So I mean, that's probably the first place to check. And along that line of reasoning and thought is these are called interlocks, and they're basically like light switches. And when the switch is off, you get no flow of electricity, so the bike don't start. A series of them are the key. Make sure it's in the right position, of course. Don't fool yourself. Give it a little jiggle. It might be sitting halfway between two. That happens too. Positions, that is. As I mentioned, the run switch, the on-off, that can also get in a little bit of an off position too. So it kind of quirks out your bike and age and things like that. So it's got to be in neutral, and the key there is you see the neutral light come on. I always like to just rock the bike back and forth, and if it's up on a stand, pull the back wheel and gear and see that it is actually in neutral. And keep going back through those interlocks. Make sure you've got the kickstand up and there's no dirt or crap or something. Or often too is the older bikes, the kickstand spring gets a little overextended and saggy and worn out, so your kickstand's like just hanging there. So effectively to the bike and its circuit, it's open and it thinks the kickstand's down. And there may be some other interlocks, like basically switches that either have to be on or off. Okay, so next step after you've verified all your keys and interlocks are in place and working, move over to the battery, and a couple quick tests you can do with the multimeter to see what state it's in. First thing to do actually is check the physical connection to the battery. The terminals, are they connected or are they all corroded and whatnot? If they're corroded, pull off the positive first and give it a good clean out. Little trick I use is just take some sandpaper and got a battery here. Take some sandpaper and where it connects in here, just take the leads out and give it a sand. Sand the washers, just a real quick one. Then you got good continuity in the battery connection. So check the battery terminals, check the condition of the battery. Is there bulges in it? Does it look weird? When's the last time it's been charged? For God's sakes, you didn't leave it out in storage, I hope. You put it back in. It's the right battery for the bike. Sometimes you can undersize them, or they come undersized. And funny is as they age, they do technically become undersized because they have less power, cranking amps in them. So about 3-year plus battery starts to get a little iffy. 4 years, yeah. I mean, you start to get into the range of battery failure and the lifespan of it going down. And the one quirk with batteries too is that it can start your bike fine, run, idle, but then it gives you a misfire at a certain speed because you may have internal bits of the battery coming apart and shorting out. Okay, this is just a quick standing charge test of the battery. So you got your multimeter, set it on to 20 volts, and it's the V with the dotted line and the straight line across the top there, if you can see that. Not this V over here, that's got the V with the wavy line, that's the AC. So you got your, first you got your leads. A little trick I learned that a long time ago was I'm positive it's red. So red is always the positive side of your battery. So you can, you don't have to take the battery out of the bike in this case, but you can certainly just disconnect the positive side for safety's sake. So what you do is just, get her on the right scale at 20 volts, stick her on there, and stick the probes right into the terminals and into the lead, leave a little mark. Then you got a good connection. So in this case, it's reading 12.83 volts. And a good battery should be between 12.6 and 14. So this one's borderline. It's acting up on the charger, and it's probably 5-6 years old at least. It was a good battery while it lasted. But anyway, and you may wonder what this strap is here. A little trick I use. This battery goes into the bike and fits into this compartment, and it's really hard to get the leads on. So what I do, I put this got it off a backpack or something, I don't know. So I've put this on there, leave it in there permanently so I can pull the battery in and out of the bike and get the leads in. I can have this up in the air a bit and get the lead on and connected, and then lower it down in. That'll work too if you got a battery that goes in sideways, you know, pull it out. Trying to get your fingers or a screwdriver in there, there's usually not much room to maneuver, so I like this little trick. So in this case, 12.6 to 14 volts. This thing's been on the trickle charger forever. It's basically, I can't trust it anymore. It's nearing the end of life, so too bad. This battery over here, it came messed up. It's in bad shape. You probably can't see it on the video. Maybe you can. It's got bulges all down the side. So each cell, this one cell in particular and this cell in particular, got major bulges in them. And let's see, it's not been, the date was never marked on here. So this one's got problems. And that's not just the way it was manufactured, because they're all different. Sometimes they have like a rounding design, but this one's got bulges in it. So this was overheated, overcharged, or maybe frozen somewhat. It's no good. It reads like 8.6 volts, so it won't take a charge and it's done. Okay, so the next test is a crank test of the battery, and then you see what residual voltage it reads. And what you want to do there is disable either the fuel injection if you have that, or the ignition system in some way. You can just pull the spark plug wires off if you like. But what you want to do is use the battery power to crank over the motor. And what you do is press the old start button for 15 seconds, a full 15, stop, and then measure the voltage. So a good healthy battery should be able to crank for 15 seconds and still have at least 9.6 volts. So 9.6 and above is healthy. Anything below it, you just have to, you get to the point where the battery has got a problem, because that's the only thing you're testing here, is the battery itself. Okay, so you might wonder what that test is all about. You know, if it cranks and starts the bike, everything's good, but not really, because if you're getting like close to 9.6 volts or below, and it's still cranking your bike and running fine, things might not be good inside the battery. You're starting to get to the point where the battery is failing, it's out of spec. So especially if you're getting like odd mid-range or kind of weird behavior from the bike, you could start to really suspect the battery. It's another, I'd say the next most likely spot to check are the fuses. And it's not completely what you think there, because you know, a blown fuse is a blown fuse, and it's usually indicating there's something serious, like a short, like a wire's got cut and it's grounding out where it shouldn't be and blowing the fuse, because that's what the fuse is designed to do. What I found in especially older bikes, and you're in a harsh environment usually, is that the fuses can get a bit corroded. So what I do is I pull them all out, maybe give them a little sandpaper, but that's not necessary. Just make sure they're not all corroded or anything, and just push them back in, because sometimes they'll kind of work their way out with heat and whatever and vibration. They'll kind of work their way out. Like I just had that happen on a car I have. The windshield wipers weren't working, and pulled the fuse out, put it back in, and for some reason they just started to work again, and they have been working since. You can also get in a case where the fuse literally cracks inside and you can't see it. There's no continuity, so it's not working. It's effectively blown. So when you pull them out, take out your multimeter and set it on ohms reading, test it out, and see if you got 0 ohms through through each fuse. Okay, we're going to scoot over to the schematic diagram. Okay, here's a quick look at a schematic and what you can get out of it just on the first glance. Start off with the legend, which is this case is up in the right hand corner. There's a bunch of standard symbols, but they may throw in some extra. So then you have the color coding itself. There's like green, yellow, they're solid colors, but they show a striped, in this case a blue wire with a black stripe is displayed with a black dash line on top. So that's just the way they portray that. Important components here are the grounds. This one looks like the main ground of the bike, judging by the number of wires that come in, and you'll notice green is pretty much the standard for ground. Okay, you notice that some of the components of the bike have their own specific grounds, and that may just be a design because they may be rubber isolated and they may be in an oil situation, so they have to have a ground. But it's good to know for troubleshooting. So there's the starter motor and the battery ground. So there's a few other ones in there. Something else to note there is an inline fuse. In this case, it's in the fan and the thermostat sensor. So in the wiring harness itself and not in the fuse box, there's a fuse. Good to know, and when you're troubleshooting that area. Okay, so we'll zoom in here on the ignition switch itself. This is where the different positions are represented in a table. You have lock and off, and nothing's going on there. Then you get down to the park position there. Three circuits are connected when you're in park. Then the on position, that's ready to go, run. That's going to give you everything, ignition circuit, the lights, all your electrical components will be ready to go, showing displayed by those dots connected together in that table format. And over here is one of the interlocks that I've been speaking about. So you've got the engine stop switch, and it's normally open, so it's also connected in with the starter switch. So when that's depressed, meaning you've stopped the engine, it's going to ground out that particular circuit and not allow the starter switch to engage and energize. And you'll notice here are these blocks. These are usually the plastic connectors, the snap connectors, and or they could be bulkhead connectors, which just means a place where one wire comes in and one wire goes out, and they're physically connected in some way. Usually snap connectors of some sort. Okay, we'll take a little tour around here. Just notice there's another interlock down here, the clutch switch itself, up on the handlebar. And just to note the way these diagrams are laid out, it's not physical layout, it's a representation, like a symbolic layout. So these parts aren't near each other at all. And here's another interlock, the neutral switch. The round drum there is representing the transmission and the gears with its own ground. And then the neutral position gives you the neutral switch and engages that line. And it's part of all the interlocks. It'll allow the ignition to be energized and the bike start and run. Okay, so looking at the schematics, the big things to get out of here are the ground points and the color of the wires and where all the connectors are. So I say after the fuses, that's the next place to start checking is the actual physical connections of your wiring. You start to bring out the tools like the multimeter, which has the ohms readings. So if you put the connection upstream and downstream of that particular ground to make sure to test the continuity. Also, you can get the these little doodads, which are quite nice. It's basically like an ohms meter. Got a battery and a light in this end, and you just clip this onto a ground point on your bike that you're okay with, and you just start dabbing around, and this will tell you if the light doesn't go on, you've got an open circuit, and between this and what should be ground, open circuit. And you don't. The nice part about this, they're cheap, and also that you don't have to mess around looking at a scale going up and down. You can just look out of even the corner of your eye and you see the light on or off, and you can really rapidly move around and check out a lot of stuff. Because you got vibration, you might have looseness, so give it a little jiggle. Don't go crazy and bend off the connector, but a little jiggle. Make sure everything's connected correctly. Also the connecting points, which I showed you on the wiring diagram, which you'll see as you go around, make sure they're actually pushed together. Sometimes they can come apart a little bit. And again, age is going to make the difference, whether you want to pop them out and check inside and give them a spray of cleaner and silicone spray around the plastic bits so they go back together nice and easy to take in and out. And you can see on the Goldwing I have, it's a classic problem with corrosion on a connector and lines. I don't know what it is from the alternator. I don't know why it in particular that does that, but there's 3 yellow wires coming from the alternator, and there's a click connector, and it's you can see the picture here. It looks like it's designed for assembly. There's no reason to have that click connector in that line, so it gets all gooey, messy, and then it starts to impede the charging. and your lights go dim, and you may not even get a start. You may get a dead battery. So that kind of thing. So you've gone down the line there, and you've done some analysis, and let's say everything's passed. Bike's say not starting, or starting rough and running crap. So the next step is the spark plugs. Okay, that wraps up part one of electrical troubleshooting, getting your bike back on the road and running fine. So, like I say, it's a little more complicated than the other troubleshooting videos. So this is the end of part one. Make sure you catch the rest in part two. Well, take her easy, and we'll talk to you soon.